gonna start recording now. Okay. Welcome to some IR practice. This is something last minute just to really nail in the idea that we want you guys to practice this kind of stuff, and you should be practicing over spring break. Yeah. So, do you guys see my my shared screen? Yeah. Okay. So the two things that we want to preface real quick, if I have my notes, there we go. Okay. Conjugation shifts your peaks to the right. Here, let me use a different color. What does this mean? So for conjugation, when you have something like a C double bonded O, like a classic carbonyl carbon, when that carbon or when that system, the carbon and the oxygen are conjugated with other pi electrons, it's going to shift that peak to the right. So your normal peak that you're going to be looking for, like between 1700 and 1720, you might see that in the 1650, 1675 region. And the reason for that is, if you remember, okay, the most common conjugated system is like an ester, right? Where you have lone pair uniform resin structures, where the hybrid looks like this. All right, this is what that hybrid looks like, where that pi bond is being shared among the two oxygens in a continuous resonance door hinge flipping. And the reason why this shifts to the right is because that bond has more carbon single bond characteristics, right? It's because if you remember, the carbon single bond to an oxygen is around the 1200, 1100 region. And if you have a resonance hybrid that pushes that characteristic a little bit, it's going to shift to the right just a little bit. So conjugation usually shifts things to the right. Additionally, you will see that in the packet, there are a couple things or a couple functional groups. You're like, what the heck is that? How did that come about? I want to preface, you will be given the molecular formula or a way to find a molecular formula, right? So if you have one of the peaks down here, you have an answer being it's an amine, right? Where you're like, how can I differentiate between an alcohol and a amine? Well, usually by the peaks or from the molecular formula that we give you or some way to find it out. Yeah, is there anything I should add? I think this. Okay. All right, that's it. I'm going to hand it off to Paige now.
All right, I guess I will add the reason that we kind of did preface that about the molecular formula is that some of these in this packet might be a little confusing if you didn't have the molecular formula, and it shouldn't be that way on the test. It'll be really obvious, like if you use the flowchart and have the molecular formula, you'll know what you have.
We also know that you will have other techniques in NMR.
Yeah, true. When we get to combined spec, which you guys don't know what that is yet, but Dr. Berg kind of mentioned NMR at the end of the last lecture. There's two different types of NMR. There's carbon NMR and there's proton NMR. And basically we're going to be using that in combination with our IR, and that'll make it a lot more be able to deduce what structure that you have. Yeah, okay. The other thing that I really want to stress throughout all of this is like using this flow chart. There's that yellow flow chart in the test 2 study materials. So like while I'm going through this, I'm going to write kind of like the progression through the flow chart on the side, because you really want to be systematic while you're doing this. So for this first one, we don't have a CO peak. So like no CO. We don't have an OH peak. That shows up usually around here. So no OH peak. Over here. And we don't have our C single bonded O peak. Usually that shows up, your chart says from 1050 to 1250. So I figured kind of some people would be confused and think that like, oh, is this a C single bonded O? But because we have the molecular formula given, we know that it's not. In the case that you didn't have this, I probably would have called this a C single bonded O peak, just in case that was a point of confusion for someone. But so since we have the formula given, no CO peak, so this is just a hydrocarbon. And it'd be some type of like alkyne with the Cl in the end. If we wanted to draw the structure, you could probably guess pretty easily what the structure is from that, because we only have 3 carbons. So there's kind of not much you can do in terms of connecting it. And the Cl would just be on the end. For most of these IR, we're not actually going to do the structure. This is kind of above and beyond. For the point of this Zoom, we really just wanted you guys to get used to using the flowchart and recognizing peaks, and we're just going to be guessing the functional group. We'll start
making points on how you can kind of hypothesize what the structure is, but the main thing is just functional groups.
Yeah. Okay, so this next one, same thing with our flow chart. Around 1720, we don't have a C double bonded O. We also know that from the molecular formula that you were given, obviously. There's no OH peak. And then let's look for a C single bonded O. We do not have a C single bonded O. That would usually be right around here, and there's no peak there. So then this is also going to be a hydrocarbon, which, yes, we knew that from the molecular formula, but we want to get you used to the flow chart. And then the other thing we're going to look at is, okay, well, is this aromatic? So right off the bat, I always look for the overtones. Those are pretty obvious. And then, of course, our OOP bends right over here. We do have OOP bends. We have one like right at 850. So actually from this, we could deduce that it would be para if we use the OOP chart. And then over here, we have some of the C double bonded C stretch. And that's also a sign of aromatic. And then the last sign of aromaticity is over here. The peaks around 1600 and 1475. So all of those are evidence that this is aromatic. The most obvious ones are usually the OOP ends or the overtones, and then these stretches over here.
Did you get the numbers?
The numbers?
Yeah. The there's just a single peak at 850.
Yeah, I wrote 850 down, but I don't actually have the chart open right now. I figured they'd be looking at the chart.
Okay.
Okay. All right, same thing for this next one. Let's just keep using the flow chart because I think I definitely want to stress to be like systematic with this because that's like the easiest way to do it. And the flow chart's really, really helpful. So no CO. Yes, OH peak. Right over here. And then we don't have a C double. Okay, so then now that we know that there's using the flow chart, no C double bonds though. Yes, OH peak. That's an alcohol. And then the other thing we can do is whether or not this is aromatic. So again, here's our overtones. Yes, we have OOP ends. 750. And then we could definitely call these our 1600 and 1475 stuff over here. The C double bonded stretches that we're kind of looking for, it's kind of obliterated by the OH peak. So don't really worry about that too much. We have enough evidence with the overtones, the OOP ends, and the peaks over here to say that this would be aromatic. The C double bonded like stretches in the front, those also get kind of obliterated with carboxylic acids too. So don't worry too much about that if you don't see it, but you see everything else. Okay. All right, this one's a little bit tricky using our flowchart. I'm thinking we probably should update it because the amines are not on the flowchart, so pending, we can do that. But we don't have a C double O, we don't have an OH, we have no CO, so like usually we would call that a hydrocarbon, right? But we have evidence of another functional group.
So I would argue that you could probably figure out that peak on the leftmost would be an OH, but because we have the molecular formula, we can't say it's an OH.
Yeah, I mean, they also do have the molecular formula, so it makes it easier. But yeah, right over here is our NH peak. So we can say that it's an amine. And then whether or not it's aromatic, same drill. Here's our C double bonded C stretch. Oh my God. Here's some overtones. We do have peaks at 1600 and 1475. And then, yes, we have OOP bends. So, aromatic. Based on the OOP bends, using that chart that we have, this is 1750, this is 690. So the two peaks around those, we could also deduce that it would be mono-substituted. If you wanted to attempt to draw the structure, we know it's aromatic and we know it's an amine. So kind of guessing, it could be something like this. Again, this is not something that you need to do with just IR, but like to get us kind of starting to think about where we're headed. This is something that we can kind of guess. We won't really, it's a lot easier to draw the structure, like I said, when we get the other NMRs that we start using. Okay. Again, no C double bonded O, no OH. No CO in our around over here. So this would also be a hydrocarbon. And then we can look for aromatic again. These are a little smaller than the other ones, but still overtones. Some C double bonded stretching. And then here's some peaks around 1600, 1475. And then of course our OOP bends. So it is aromatic. You could also calculate like DU because we have a molecular formula, and that would probably give you, hopefully a 4 or 5, and then Dr. Berg would draw that little flag to show you that it's going to be aromatic. Okay. And then this one, there's going to be some functional groups that you'll get used to, like right off the bat, just looking at this. Like, I know that this is a carboxylic acid because we have this monster peak over here. Alcohols and carboxylic acids are like the easiest one. Like the OH peak here is kind of skinny. For carboxylic acids, like it's huge. So once you kind of get used to looking at spec, those are going to be the two functional groups that like you'll look at spec and just instantly know the functional group. But we'll still use the flowchart. Here's our C double bonded O. Yes, CO, yes, OH, carboxylic acid. And then in terms of aromatic, I did say that the C double bonded stretches do kind of get messed up when we have a carboxylic acid, so we can't really tell anything there. I'm not seeing any overtones, but that might be because of this peak right here at 1720. But since there's no OOP bends, I'm not really looking like there's no aromatic evidence from this IR. Okay. For this one, our DU is 5. So that's a red flag. Oop bend peaks at 1600, 1475. And then we got some stretches over here. So this one's also aromatic. Following our flow chart to, oh, my OneNote is dying. Our flow chart to determine the functional group. I mean, it's a little obvious from the molecular formula that you guys were given. You won't normally just be given a molecular formula. You'll either be given that or you'll be given a way to find the molecular formula, as Patrick said.
In the most common ways, the
Percentage.
percent,
Yeah, the percents, or sometimes he does do rule of 13. Well, he gives you
yeah, rule of 13, the percent.
Yeah, he'll give you a molecular weight, and you have to use rule of 13 to find it. Either way. No OH, no C double bond, no C single bonded O, and then hydrocarbon. Okay. Oh, almost forgot. Overtones. Okay. Now this one, we are given the molecular formula, so again, we could do DU, and then we know that it's not going to be aromatic, but to stress like what we're looking for, there's no overtones. We don't have any oop end. We don't have any peaks really that are distinctive around the 1600 area, so not having the oop bends, not having overtones, not aromatic. And then in terms of functional group, we can use our flow chart again. Around 1720, we have no C double bonded O. So then the next thing we look for is the alcohol, no OH peak. Then the next thing we look for is the C single bonded O. We don't have that over here either. If we were actually given this without a molecular formula, this molecular formula is kind of not really following our regular progression. If we were giving this to you on a test, we would probably have you go ahead and call this a hydrocarbon because you wouldn't be given this and you'd probably be given like percent carbon, percent hydrogen, and then you would continue like that. So some of these are a little confusing. This was kind of taken from a textbook that is above our class.
Oh yeah.
So that's kind of why we definitely prefaced in the beginning this whole you'll be given a way to find the molecular formula thing. So hopefully they don't confuse you too much. This was kind of just an attempt to give you guys more practice.
Again, reemphasize, they will give you more information, like usually for combined spec.
Yeah.
Like you'll also most likely have a proton and carbon in one.
Yeah, we don't like that. Okay. Down for this next one. Okay. This is gonna kind of come back to us later, so I'll look at this. We're using it got split up, but this is attached. We're here we're given two structures, and really the difference here is that this has a conjugated system and this one's not conjugated. And then the thing that Patrick stressed in the beginning, which we definitely want you guys to take away, and you'll see it a lot more as we keep doing more spec, that conjugation shifts your C double O. Oh my God, please. To the right. So if it was this structure, we would expect our C double O P to be shifted to the right, and this one would be more to the left. So then looking at this IR down here, okay, here's our C double O peak. So then we're gonna look for an OH. We have no OH. No Fermi doublet. Fermi doublet would be over here. But we're looking for those two peaks at 2820 and 2720.
No, those are Fermi doublets. These are aldehydes. Because the second peak is being eaten up by the major.
Oh, wow. See, okay. That he wouldn't give you a spec that was that dirty. For like the Fermi doublet, like you really do want to look for peaks that are like, because I know a lot of these, like when we give them the range, like I've been getting the question a lot, like, oh, how much like out of range from 720 can it be? And like I know it gets a little subjective.
This is also low resolution.
Low
The test will have pretty clear peaks.
The Fermi doublet is kind of the number that like I remember Berg when I was taking OChem, because it was also a little confusing, like how much can it be off to count. He said the Fermi doublet was like pretty rigid, like you want to like stick to like numbers that are around like 28,000 and 27,000, and they should be like around
that outline so that they can see like the first peak and then like the one that's kind of eaten up on the side.
Yeah, and then I guess that would be the second one. But it's kind of, yeah, it's like sucked into this one. That's really gross. I don't like that.
Yeah.
Okay. Why do they keep asking you to pay for Zoom?
I don't know. Just finish your thing, and I might have to open up or reopen this Zoom session, and then I'll just hit record again.
Okay.
That's up you guys. Again.
I guess we can stop here. I was just
in 10 minutes. Finish your own set.
Okay. Sorry about the Fermi doublet thing, but like I guess that kind of shows you how grateful you should be that you're going to be given nice spec on the exam instead of kind of a messy one like this. And I was kind of doing it a little fast. That's my bad. But to the point that we wanted to get you guys from this one is that this is like right at 1720. So it's not shifted to the right. So that shows us that we don't want this one. It's not going to be the one that's conjugated, because that would shift our peak from 1720 more to the right, but our peak isn't that. So that means that we have citronelle. I don't know how to say that, but that's the one that we have, because this shows us that it's not conjugated. And then the last thing that we're going to check, again, aromatic. We don't have overtones. We don't have oop. We don't have peaks around 1600 and 1475. My OneNote is really struggling. So this is not aromatic. Okay. Patrick, do you want to stop it now? Because my OneNote's kind of freaking out anyways.
Okay. I'll stop it now and I'll restart the session.
Okay. All right, just to pick up on that last one where we left off, since this does have a Fermi doublet, we're an aldehyde, and that brings us to like the end of our little flowchart thing. And then the next one. Here, we start off, we have a CO. No. Around 1200. We have no C single L, no OH. Hold on. Okay. And then this is okay. And then here, these like really small peaks we can call our Fermi doublet. And then that brings us through like the whole progression of the flow chart. And this would be an aldehyde again. And then in terms of aromatic, we don't really have much to say whether or not to be aromatic. You can look around 1400, 1475. Yeah, we're like missing these peaks. No. These probably could be oop ends. We have like a little bit of overtones over here. And then this probably could be like water or something. That wouldn't be a C stretch, but these could be a C to 1 stretch. So I would call this aromatic. Okay. And then down here, starting with our chart, around 1720, no C double bonded O. Over here, yes, OH. So that's an alcohol.
The one right below that is the same thing, but the difference between the two is like cis and trans. We're not doing that. So you can just skip the next one.
Okay, that's cool. They will not be asked that on an exam.
Yeah,
so
we don't use cis trans though.
I literally don't even know how to do that.
Neither. Talking about the brain, like, oh yeah, don't do that.
Okay. That's probably in like the 5,000 level class identification of the spec thing. I'm sure it would be. Okay. We can determine whether or not this is aromatic. We don't have oop. So kind of right away, I'm thinking it's probably not aromatic. We can't really check for the C stretches. The alcohol kind of ruins that. So I'm gonna say this is not aromatic because we don't have oop and we don't have any of the 1600 and 1475. All right. This one right away, I can tell that it's an alcohol because we have our OH peak, but we'll go through the flow chart. 1720, we have no C double bonded O. Yes, OH, alcohol. Okay, and then aromaticity, we don't really have any overtones. We don't have those peaks over here. 1600, 1475. So, and then no oop. Not aromatic. Okay. And then this last one right here. This is our C double bonded L. We have no OH. And then now we're gonna look for a C single bonded L, which could be probably these. No, sorry, yes. CO. So then that means we have an ester as our functional group. And then in terms of whether or not this is aromatic, we have our oop ends. These are the two peaks that I would pay attention to, 1750, 690. Using our oop chart, we could determine the substitution. If I have that chart memorized off the top of my head, I think that should be mono-substituted. I don't know if I have that memorized. Patrick should probably check that. Okay, that's good. And then this is our overtones. And then looking for our 1600, we can call it that one, 1475. I don't know, one of these. But yeah, we do have our aromatic peaks. So I would call this aromatic and ester. Okay. Back up.
Yeah. Oh, no, you're good. It's my go.
Yeah.
Okay.
I think you're muted.
Okay. Yeah, we have a C double bonded O. We don't have an OH peak right here. There's no, or you can make an argument that those are overtones, but really we don't really see a whole lot of sp2 carbon stuff here. And just to check, we do not have a 1600. I should probably do that in purple. We do not have a 1600 and a 1475 peak. This is not going to be aromatic. And indicative of a ketone, we don't really have anything. We have lack of evidence of other functional groups. And I don't see Fermi doublets, so this is going to be a ketone. Now, if you look above it, we have different cyclic ketones. The book that this is derived from is asking you which one it is. You don't have to know that. That's what proton NMR we're using for, plus the molecular formula you will be given. All right. Next up right here, we have another peak. We are looking here. We don't have a 1700 peak, so there's no carbon double bonded O. We do have some peaks here. You might be thinking, is that an OH peak? No, an OH peak would normally be kind of like a clean hump. However, we have two distinct humps, and that will be two different NH peaks, right? Two different NH peaks. So if you had a mono-substituted amine, you would only have one of those peaks and be relatively pointy. But this one, you have two peaks. So most likely you're going to have one of these groups that have two NH peaks. So it's not going to be A or B. Next up, we're going to look at aromaticity. I see some overtones here, and I do see some carbon double bonded carbon peaks here. And I also see a 1600 and a 1475. All right. Additionally, I see a peak that is only 750. So that would be ortho substituted. So most likely it's going to be D. And again, the point of this packet is just to look at functional groups. You don't actually have to pick a one of the compounds. This is an amine. All right. Okay. Next up, again, let's take a look. We do have a C double bonded O. All right. Do we have an alcohol? There's no alcohol group. All right. Is there a single bonded O? Yes. There's a single bonded. A single bond O section. And because of that, it's good to think that that is going to be a ester. All right. Additionally, we have some overtones. We have some C double bonded C sections. Additionally, we do have a 1600 and a little bit of a slight 1475, 1600, 1475. And then we have a 700 and a 690. 750, my bad. 90. That's going to be mono substituted. So it is aromatic. It's going to be an ester, and it's going to be mono substituted. Right. Next, let's go from flowchart. Do we have a double bonded single bond? oxygen double bond? The answer is yes. All right, now let's look. We have an OH. We do not have an OH stretch. Next up, do we have a carbon oxygen single bond stretch? No, we do not. There's no major peak there. All right. And with that being said, we kind of have a lack of evidence of anything else, so we are safe to say that it's going to be a ketone of some kind. Now, if you look above, there are a numerous amount of compounds. You don't have to analyze it that deeply unless we have other spectra, because you can determine this with proton NMR. But because we have we do not have a single bonded CO stretch, we cannot choose B or D. It's probably going to be A or C. Right. The next one, again, we have a C double bonded O. Do we have an alcohol group? There's no alcohol group. Do we have a C single bonded to an O? No, there's no C single bonded O. Now let's look at this aromatic. There's no overtones. We do see some C double bonded C over here. And we do not have a 1600 and a 1475. So we cannot deduce that it is aromatic. Now, what I want to make note is that your peak for C double bonded O is 6075, which is a little less than what we have, and we have a C double bonded C. So I'm kind of thinking it's going to be C, because that ketone is going to be conjugated. If it's conjugated, it's going to shift to the right a little bit. All right, next, let's run it back again. This, we have a C double bonded O, right? Do we have a carbon oxygen, or not a carbon oxygen, an OH peak? No, we do not. You do not have an OH, so do we have a CO single bond stretch? We do not. No CO. So I'm using that flowchart, we're going to think it's either going to be an aldehyde or it's going to be a ketone. And looking right over here, you have those peaks. That's going to be our Fermi doublet. Not that one. This one. 2820 and 2720. And if you look up here, that actually fits our different options because all of these have aldehydes. So it is an aldehyde. Again, for this packet, don't worry about picking the right structure here because there's some stuff that's not asked about. Like for this one, it's asking about like cis trans again, and then the alkenes. Don't worry about that. That's not what we're going for. Again, let's take a look. We have a C double bonded O. Do we have an oxygen hydrogen bond? No. Do we have any C single bonded O? I would say, I don't know if that would be strong enough. I would say yeah, actually. Single bonded O. I don't see any overtones. I don't see any C double bonded C sections, or do I see a 1600 and 1450? So with this IR, I would deduce that would be an ester. Now, if you look at the ones above, we see ketones and aldehydes. Though I said an ester, you could be given a molecular formula where you only have one oxygen, and thus you can better choose. An ester has to have two oxygens at least, so it's probably going to be not an ester. But if it's just the IR, this looks like it's going to be an ester. All right, so again, ignore the stuff above because that's a lot deeper than we're actually going to be going with. Okay. This one, we have C double bonded O. We do not have an OH bond. We do not have actually, I made C single bonded O. We do not have any overtones. We do not have 1600 and 1475, nor do we have C double bonded C stretches. So my money is this is going to be an ester. And again, if you look above, those are nitrogens. Yeah, they're nitrogens. You can't really take that with the IR we have at hand. You need more information, which we will give you. So again, ignore the stuff above. Okay, the next one. So we do not have a C double bonded O section. we do not have an OH stretch, nor do we have a C single bonded O. Lack of anything, even the lack of a C double bonded O, is going to be hydrocarbon-like. Moreover, no overtones, no C double bonded C, no 1600 and 1475 peaks. We're not looking at that. Next two are relatively tough, but this one, there's no C double bonded O. Let's look for the OH. There's no OH peak, and there's no C single bonded O. So it's going to be hydrocarbon-like. So my money is going to be a hydrocarbon. Next, we do have a C double bonded O section. I don't know why I did that in purple. I do suck. No OH. We don't really have a major ester peak, but I guess you need more information.
Yeah, you can't. That's not a distinct enough.
I don't think that's distinct enough. It's too mixed up, so I would not do that. Again, you would have more information. Yeah. So lack of anything else is probably gonna be ketone. Let's double check for aromaticity. No overtones, no 1600 or 1450. There's no seasoning. No. Oh, the one above it, we do have overtones. I think that is 1600, 1450. C double bond C, and we do have some oop bending. So this would be aromatic. Okay. Yeah. All right, that's I'm gonna stop my share. Okay.
You have to do that really fast.
Yeah. Well, my laptop's about to die. So all right. The recording's done. Do you guys have any last minute questions? Let me stop the recording.